In this section, we want to learn about how to graph tangent, cotangent, secant, and cosecant function. Let's start with the graph of tangent. Tangent is defined as sine over cosine. We know that cosine function is a wave function. There are infinitely many zeros. That implies the tangent function is undefined at infinitely many points. What I'm trying to say is 1 over 0 is undefined. And if you think about the graph of cosine, then pi over 2, this is 3 pi over 2, this is 5 pi over 2, and so on. This is minus pi over 2. Whenever cosine theta becomes 0, it makes tangent value undefined because the denominator will become 0. So we can say that the domain of the tangent function is all real numbers except 2n plus 1 times pi over 2 when n is an integer. 2n plus 1 times pi is odd multiple of pi. So 1, 3, 5, those are odd multiple of pi. More explicitly, when cosine of theta equals 0. Tangent is defined as sine over cosine. That is a fraction form of the function. So when the function is a fraction of the functions, then there are vertical asymptotes. Whenever the denominator, cosine of theta, becomes 0. X equals 2n plus 1 pi over 2. This time x equals this one is the equation of the vertical line. What is strikingly different in tangent function compared to sine and cosine function, the range of the tangent function is from minus infinity to infinity. Let's explore why that happens. Let's go back to the unit circle. We have a unit circle here. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. 1, 1, minus 1, minus 1. And let's say this is theta. Then what we know about the unit circle is the coordinates represent cosine and sine. Cosine of theta for x coordinate, sine of theta for the y coordinate. What we know is tangent functions are undefined at odd multiple of pi over 2. So tangent functions are not defined here because x coordinate is 0 and 1 over 0 becomes undefined. What we want to think about is why the range is from minus infinity to infinity. Let's consider what happens when theta goes to pi over 2 minus, that means from the smaller value. So we are moving the angle this direction. So angle is smaller than pi over 2, and we are approaching to this vertical positive y-axis. If pi moves to pi over 2 from the smaller angle, what we notice is cosine of theta goes to 0 plus. Plus means from the larger value. So it approaches 0 from 0 point something, and but it never becomes 0. If we observe sine of theta, sine will approach to 1. However, as we move toward pi over 2, the y value increases and gets closer and closer to 1, but this time it is from the smaller value. Let's keep in mind that tangent of theta equals sine of theta over cosine of theta. So we can rewrite that as sine of theta times 1 over cosine of theta. What we want to do is we want to observe what happens to this component and what happens to this component. To make things more intuitive, let's interpret the first one. Cosine theta goes to 0 from the larger value than 0. Then the example may be 1 over 10, 1 over 100, 1 over 1000, and so on. It gets smaller and smaller, and then approaches 0. In the tangent function, what we have to consider is 1 over cosine of theta. So we will think about the reciprocal of cosine of theta. Then we will realize that that diverges to infinity because we have to flip each fraction. 10, 100, 1000. So it gets larger and larger forever. If we think about sine approaches 1 from the smaller value, then the meaning of that is something like this: 0.9 and 0.99, 0.999. It gets larger and larger, but it doesn't go to infinity this time. It approaches 1. Let's combine all those information to think about the behavior of this tangent function. Let me write it down again. Tangent of theta could be written as sine of theta times 1 over cosine of theta. What we know about both is both components will get larger and larger. So you can say that when you multiply two numbers and both numbers are getting larger and larger, then you can say that this whole thing will get larger. What we want to think about is where it goes to, because sometimes it can be bounded, like sine function. What we observed was sine function will go to 1, and cosine, 1 over cosine, will go to infinity. Even if, so when we multiply both numbers, the multiplied numbers will be smaller than 1 over cosine of theta, but one gets larger and larger and diverges to infinity. Then apparently when we multiply those two numbers, those multiplication will go to infinity. So tangent function value will diverge. So range will be minus infinity to infinity. You can do the same reasoning by locating the angle on the left side. Then this time cosine value will stay negative all the time. So while we do the same reasoning, the divergence happens to negative infinity. This reasoning is a little bit out of scope of discourse. So if you cannot understand it well, then you can just remember that tangent function is defined as fraction sine over cosine. Whenever cosine is 0, tangent function will have vertical asymptote, and at the vertical asymptote, the tangent function will diverge either to infinity or negative infinity. The next thing I want to discuss is about the period. Let's go back to the unit circle again. Let's say this point is A and this point is B. And then that is the opposite point, so it becomes negative A and negative B. This is theta, and then we think about this angle, then that is theta plus pi, because this is theta and this amount is pi. Let's consider tangent of theta. Then tangent of theta is defined as b over a, because sine over cosine. By considering the purely algebraic thing, we can rewrite that as minus b over minus a. Those are equivalent fraction because minus and minus can cancel each other. Minus b over minus a is defined by this point. The angle associated to that point is theta plus pi. So tangent of theta plus pi. From here, we can conclude that whenever we have theta, if we move pi amount, then we will get the same tangent value. But if you go smaller angle than pi, then it'll never become the same fraction. So that pi is the minimum value which makes the tangent value the same. So period of the tangent function is pi. This is very important. Many people think that is 2 pi. That is not. Always think about what happens here. Tangent function is odd function property. Let's see why that happens. Tangent of minus theta can be rewritten as sine of minus theta over cosine of minus theta. What we already know is a sine function is an odd function, meaning we can pull out that negative value in front of sine function over cosine of theta, because cosine is an even function. When we switch the input value sine, the function value stays the same. From here, we can rewrite that as minus tangent of theta by looking at sine over cosine, and minus is attached to that. Let's summarize the tangent function, which is defined as tangent function property, which is defined as a fraction form. Tangent of theta is sine of theta over cosine of theta. When you look at this, what you would think about would be 1 over 0 equals 0, and 0 over 1 equals 0, and 1 over 0 is undefined. This property determined the vertical asymptote x equals 2n plus 1 pi over 2. And that is about cosine. And this property, if the sine value equals 0, then the function value becomes 0. So that means n times pi by considering the sine function. Let's combine all the information to draw tangent function. Y equals tangent of x, again, sine of x over cosine of x. In the sine and cosine function, we thought about the period, and then we thought about the key points. But when we think about the tangent function, we will think about where we have vertical asymptotes and where we have zeros. There are two important key points for each period. I said odd multiple of pi over 2 will initiate the vertical asymptotes because cosine function is the 0 and the fraction is undefined, so tangent is undefined. Other important thing you have to observe from the graph will be 0 to pi. If you think about the quadrant and 0 to pi, then that belongs to quadrant 1. And if you think about 0 to minus pi, then if this is a quadrant, then angle goes this way. So that is quadrant 4. What we discussed was the divergence property. When it approaches pi over 2 from the smaller value, the function diverges, and when sine value equals 0, meaning when it passes the origin, tangent, when angle is 0, it passes the origin because sine value becomes 0 there. The only way that can happen is when the graph looks like this. The graph will get closer and closer to this vertical line, but never cross the vertical line. I said in the fourth quadrant, in that quadrant, sine value is negative, so the tangent value is negative, so entire tangent graph in the fourth quadrant will stay below x-axis, and the same argument will happen. So this is the graph. When we discuss the tangent graph, this is the one cycle. Because of that, we repeat the same pattern over and over again, like this. Other important thing you have to remember is when the first vertical asymptote appears, that is identical to the half of the period. If you go another half of the period, then you will hit 0, and then if you add another half of the period, then you will get the vertical line. Let's generalize the formula. Period of y equals tangent of b theta. This time, that becomes pi over absolute value of b. What is important to remember is that is not 2 pi over absolute value of b. If the period became pi over absolute value of b, then the first vertical asymptote will happen at x equals 1 over 2 times pi over absolute value of b. The next problem is finding the period of y equals minus 3 times tangent of 2 pi x and graph it. Period formula was pi over the number in front of x, 2 pi, which is 1 over 2. Then we will figure out what the first vertical asymptote is. That is x equals 1 over 2 half of the period, which is 1/4. If you look at the tangent function, the given function, then the period is adjusted and there is some vertical stretch that'll make the graph taller and thinner and grow faster, and there is a vertical reflection. What we want to do is we want to graph the tangent function without a vertical reflection, 3 tangent of 2 pi x. This is the first vertical asymptote. Then all we have to do is adding 1/4 and then 1/2 and 3/4 and 4 over 4 is 1, then 5 over 4. This is minus 1 over 4, and this is minus 1 over 2, and this is minus 3 over 4, and this is minus 1. Here is the vertical asymptote. This is just the tangent graph whose period and period is adjusted, and which is vertically stretched. So, but the shape of the tangent function will stay the same. In the quadrant, that'll be positive. In quadrant 1, that is positive. In quadrant 4, that is negative. The next step is flipping along x-axis. Let me draw it together. We put negative to the entire function, so it'll switch the value, y value. So positive will become negative and negative will become positive. So the pattern of the graph will look like this. That green graph is the final answer. We do exactly the same argument for the graph of y equals cotangent of theta. Cotangent of theta is defined as cosine of theta over sine of theta. This time, sine is in the denominator and cosine is in the numerator. So cosine will determine zeros and sine will determine vertical asymptotes. Where the function is not defined. So domain is all real numbers except when sine value equals 0, except n times pi, n is an integer, where sine of theta becomes 0. So you just imagine the graph of sine. This is pi, this is 2 pi, and so on. I said this determines the vertical asymptote. Vertical asymptotes are x equals n times pi. I said this is the equation of the vertical line. With the same argument, we can conclude that the range of cotangent is from minus infinity to infinity. And period, because of the same reason, period is pi. Cotangent function is also odd function. You can write down cosine over sine. Sine is an odd function, so we can say that cosine of minus theta is minus cotangent of theta. By switching the numerator and denominator, sine of theta produced the vertical asymptote. So whenever sine becomes 0, there will be vertical asymptote. Those are pi, 2 pi, 3 pi, and so on. Let's draw the graph of cotangent. This time, n times pi will be vertical asymptote. So first the vertical asymptote is pi. If you think about the zeros, when cosine of theta equals 0, meaning whenever theta becomes 2n plus 1 pi over 2, we have zeros. If you think about the cotangent functions graph, then again, this is pi over 2, this is 3 pi over 2, and odd multiple of pi over 2. So this time, the first vertical asymptote appears at the period, and half of the period become 0. But what you can notice here is whenever we add half of the period, something meaningful happens. It becomes either 0 or vertical asymptote. We do the same reasoning when we graph the range of cotangent function is minus infinity to infinity. We have to decide whether the graph goes up or down. To do that, what you will observe is a 0 to pi is quadrant 1, everything is positive. In pi over 2 to pi, which is the quadrant 2, cosine value is negative, so, and sine value is positive, so cotangent value will be plus over minus, which is negative. So it rises when it approaches y value, and it falls when it approaches pi. That is the graph of cotangent. Let's generalize the period of cotangent. When something is multiplied to x, that is pi over absolute value of b. Again, that is not 2 pi over absolute value of b. Let's find the period of y equals cotangent of pi over 2x and graph it. We will use the period formula. Period was pi over 2. This is the numerator. This is the denominator. So we can rewrite that as pi times 2 over pi. So these two will cancel each other to make 2. So first vertical line will occur when that is 2, but half of the period will become 0. So this positive number belongs to the first quadrant. So in this region, the graph should be positive. So this is the graph, desired graph, and we will just patch those graph forever. That's about the graph of a cotangent function. The next one is the graph of secant function. Secant function is another fraction function that is 1 over cosine of x. But the numerator will never become 0. That means secant function doesn't have any 0. What we discussed previously was the domain is all real numbers except the x value, which makes the denominator, which is cosine value, 0. All real numbers except 2n plus 1 over 2. This point where the function is undefined will make the vertical asymptotes. So that is x equals 2n plus 1 pi over 2. The way we graph a secant function, that is defined as the reciprocal of the cosine function. So we will graph the cosine function first, and then we will think about the graphical shape of 1 over cosine. Cosine is bounded by 1 and -1. This is the graph of cosine. Y equals cosine of x. And then we discussed the vertical asymptote. Whenever cosine becomes 0, the secant function is undefined. So let's specify the vertical asymptotes. We are thinking about the reciprocal function. At this point, cosine function value becomes 1. So 1 over 1 is 1. And at this point, cosine value is minus 1. Minus 1 over minus 1 is minus 1. So maximum of the cosine function will become, this time, local minimum of the secant function. And the minimum of the cosine value will become a local maximum of the secant function. What we discussed before is when cosine value becomes smaller and smaller, its reciprocal value will become larger and larger. And between this and this point, minus pi over 2 to pi over 2, cosine value stays positive, meaning when we think about the reciprocal, all the reciprocal will become positive value. So graph should stay above x-axis, but if that is smaller than 1, then 1 over smaller than 1 value will become larger than 1, and those are vertical asymptotes where secant will diverge. The only way that can happen will be by flipping the shape under that curve. But it has asymptote, it will never touch the vertical line. So n-shape part in cosine function will become u-shape in the secant function, and u-shape in cosine will become n-shape in secant. So that will be patch of u and n-shape function. This green part graph will become y equals secant of x. Let's look at the graph and clarify further about the range of the secant function. The range of the secant function is from minus infinity to minus 1. It falls forever to negative direction, but it has local maximum at minus 1. That's the meaning of this. Union, it goes up starting from 1, so 1 to infinity. It doesn't have any value between minus 1 and 1. As in the cosine function, period is 2 pi, just a n-shape and u-shape patch, and that is an even function because secant of minus x equals 1 over cosine of minus x. That is 1 over cosine of x. Cosine of x is an even function, so cosine those will be the same. Therefore, we can write it down as secant of x. So we know secant of minus x equals secant of x. In this problem, we want to consider the period of y equals 4 secant of 2 pi x, and by using that information, we want to graph it. Y equals 4 times secant of 2 pi x can be rewritten as y equal 4 over cosine of 2 pi x. Our strategy will be we will graph cosine of 2 pi x, and then we will think about the reciprocal of that but we have to consider this multiplication by 4. To graph the cosine function, let's do just step 1. We want to figure out the graph of y equals cosine of 2 pi x. It has no vertical stretch or any phase shift. It has just an adjustment with the period. Period of cosine was 2 pi over 2 pi. That equals 1. So from here, we figured out the key points. We drew the interval from 0 to 1, and then we subdivide into 4 equal intervals. So this becomes 1/4, 1/2, 3/4, and so on. By using that, we will draw the cosine. The maximum will be 1 and minimum will be -1. The general shape will stay the same because there is no vertical reflection. This is the graph y equals cosine of 2 pi x. After that, we will identify the vertical asymptote. Whenever that becomes 0, we will have vertical asymptote. Two, three, 4. What you have to be careful is there is a multiplication by 4. So 1 times 4 will become 4. So this time local minimum will become 4 and local maximum will become -4. If we think about this point, that is 4 over 1. Cosine value is 1, so that becomes 4. In the same way, if this is -1, then 4 over -1 will become -1. The same thing goes on and on like that. What I said was it'll just flip the shape where while it keep the vertical asymptotes. So N shape becomes a U shape, and U shape will become an N shape, and it looks like this. So that is the final graph for y equals 4 times secant of 2 pi x. Let's graph cosecant function. This time, the denominator becomes sine, but working principle will stay the same. Domain is the point which doesn't make the denominator 0. So all real numbers except n times pi, where sine of x equals 0. Just imagine the graph of sine. Pi, 2 pi, and so on. I said whenever something is, this fraction form is undefined, it causes vertical asymptotes. But vertical asymptote is x equals n times pi when n is an integer. So the same. Let's draw the graph of cosecant function. What we do is we first draw the graph of sine, and then we will think about the reciprocal of that. Let's draw the graph of sine function first to identify the vertical asymptote and flip the shape of the graph as we did in the secant function. This is y equals sine of x. Now we are identifying the vertical asymptote where sine value is 0. Those are pi, 2 pi, 3 pi, and so on. We are thinking about the reciprocal of this function. So 1 over 1 will be 1, and 1 over -1 will be -1. 1 over 1 is 1, and so on. So they have the point they are sharing, but we are thinking about the reciprocal. So when the function value gets smaller and smaller, the reciprocal will get larger and larger. If original function is positive, and then 1 over something will be also positive. When that happens, the only way that can happen will be when the graph shape looks like this. If the function value is negative, then 1 over something will become negative, so it becomes like that. So this red graph is the graph of y equals cosecant of x. We use the sine graph and we just think about the reciprocal of a sine function value. So the period for cosecant function is 2 pi and range is from minus infinity to minus 1 union 1 to infinity. This time cosecant function is an odd function because cosecant function is defined as 1 over sine of x. Let's put minus x, then that is sine of minus x. Since sine is an odd function, we can put minus in front of sine of x. So we can say that is this one, 1 over sine of x is cosecant of x, and minus was there, so we put minus here. So cosecant of minus x equals minus cosecant of x. Therefore, that is an odd function. Let's do the application problem. Find the period of y equals 3 times cosecant of pi over 2x and graph it. The period formula for cosecant function is 2 pi divided by the number in front of x. This is numerator, this is denominator, so we can rewrite that as 2 pi times reciprocal of that, the denominator. So pi and pi will cancel each other, and this 2 and this 2 will multiply together and becomes 4. Key points will be obviously 1, 2, 3, 4. Our strategy will be graphing sine of pi over 2x because we are understanding this function as 3 times 1 over sine of pi over 2x, or just 3 over sine of pi over 2x. And then we will just graph the cosecant function. We are drawing the sine function, so it should start at the origin. This is the graph y equals sine of pi over 2x. So let's do 2 and 3 minus 2 and minus 3. What we are thinking about is sine of pi over 2x at this point is 1. If you multiply by 3, then it'll become 3. And we can say similar when this value is negative 1. If you multiply by 3, then it'll become minus 3. So this bound will become 3 and minus 3. Let's put the vertical asymptote whenever sine value becomes 0. So we want to graph y equals 3 times cosecant of pi over 2x, which was 3 times 1 over sine of pi over 2x. I said 1 times 3 will make 3, and 1 minus 1 times 3 will make minus 3, and so on. After we identify the local maximum and minimum, all we have to do is we just flip the shape of the original function, sine of pi over 2x. The green graphs are the graph of 3 times cosecant of pi over 2x.